In this video, we're going to talk about acidosis and alkalosis. And just as a precursor to acidosis and alkalosis, we just need to understand what are the different types of buffer systems, okay, buffers in the human body. And the reason we need to understand this is because this is what gives rise to acidosis and alkalosis, okay? So, the first system that is probably the most common system is, is the bicarbonate system, which is simply H2CO3 and HCO3 minus. That's the most common buffer system. That's number one. Number two is your phosphate system, which is your H2PO4 minus and then HPO42 minus. Okay, that's your bicarbonate buffer. This one's your phosphate buffer. And then on a cellular level, you can also have a protein, your proteins that act as buffers. And then you also have hemoglobin. Okay, so but right now our discussion is going to focus principally on the bicarbonate buffer system to explain acidosis and alkalosis. Okay, so let's take a look at how this buffer works. Okay, so when people respire, okay, so when they breathe in air, they breathe in oxygen, and so oxygen comes in, okay, and then they breathe out carbon dioxide. Okay, so it all begins with the carbon dioxide that's breathed out. So you have carbon dioxide plus water gives you, when you combine that, it gives you H2CO3, which is your carbonic acid. That's carbonic acid, and that's a weak acid. It's one part of the buffer, and then there's an equilibrium that sets in between the carbonic acid, so it dissociates to form HCO3 minus. That's the conjugate base, and this is also known as this is also called a bicarbonate ion. Okay, and then you have H3O plus. Okay, so now if you think about when the carbon dioxide level goes up, so when carbon dioxide level goes up, the equilibrium basically, Le Chatelier's principle basically states that the equilibrium moves to the right. Okay, so if the equilibrium moves to the right, you have more of H2CO3 forming. Correspondingly, that's going to create more HCO3 minus, and if the carbon dioxide is uncontrolled, usually the HCO3 minus, kind of buffers it. But what happens is if the amount of carbon dioxide is uncontrolled, that means there's too much carbon dioxide for this system to, work properly. As a result, the acidity, okay, so therefore you have too much H3O plus. As a result, the pH drops, okay, goes down, okay, and then you have what we call acidosis. Okay, now on the other hand, if you have carbon dioxide levels depleting, okay, and when those carbon dioxide levels deplete, what happens is obviously what's on the left side goes down. So Le Chatelier's principle states that the equilibrium is going to shift to the left, and if it keeps going, you have a decrease of H3O plus. As a result, the pH rises, okay, resulting in alkalosis. Okay, so now that we understand that, let's try to understand what are the conditions under which acidosis and alkalosis take place. So very simply, so if carbon dioxide increases, that results in acidosis. Okay, and this is, to be very precise, this is respiratory acidosis. And if carbon dioxide decreases, that results in alkalosis. Again, same, it's respiratory, okay? And this acidosis usually takes place when in genetic diseases, in genetic diseases like cystic fibrosis. It could also be, any kind of lung disease, when your lungs are not expelling carbon dioxide at the appropriate rate, so there's a lot of buildup of carbon dioxide. Alkalosis, on the other hand, takes place when you're hyperventilating, which basically means you're breathing too fast. That happens usually after a lot of exercise. Okay. And as a result of hyperventilation, you're expelling a lot more carbon dioxide than you should be. And because of that, you go into alkalosis. Okay, so that's one part of that's respiratory acidosis or alkalosis. Now, there's another kind of acidosis and alkalosis that we want to talk about here. I'm going to go ahead and write this equation again. You have carbon dioxide plus water gives you H2CO3 plus H2O, and that gives you HCO3 minus plus H3O plus. Okay, so a lot of times when you eat a lot of acidic food, okay, or due to some problem in your body, something like sepsis. So let's take, for example, when you have, I don't know why this is not writing. So when you have, okay, here we go. You have sepsis setting in, okay, or if you're suffering from diabetes, okay, then as a result of that, excessive acid is produced. When excessive acid is produced, that's this term, pH goes down. As a result of that, you have acidosis. And that acidosis is called metabolic acidosis, okay? At the same time, when you have excessive vomiting, or rather, on the other hand, if you have excessive vomiting, you throw up too much, it could be due to any reason, then your H3O plus ends up being expelled, because H3O plus comes from your stomach acid. And because the H3 plus comes out, what's going to happen is your pH goes up, okay, because now you have less H3O plus, so the pH goes up, resulting in alkalosis, also known as metabolic alkalosis. So that's acidosis and alkalosis kind of in a nutshell for you.